In 1938, a dead fish on a pile of sharks changed everything we thought we knew about evolution. Not because it was new, but because it was supposed to be impossible. And inside its fins was a bone pattern you'd recognize, because it's the same one inside your arm right now. December 22nd, 1938, East London, South Africa. Marjorie Courtenay-Latimer was a 32-year-old museum curator. She had an arrangement with local fishermen. Anything unusual in their catch, they'd let her see it first. That day, Captain Hendrik Goosen called her down to the docks. Buried under a pile of sharks and rays was something that made no sense. It was 5 feet long, steel blue, covered in thick, armored scales that felt like armor plating. And its fins didn't look like fins. They looked like limbs. She didn't know what it was, but she knew it mattered. She fought to preserve it in the South African summer heat, with no proper facilities, wrapping it in rags and desperately trying to save it before it rotted. She sent a sketch to Professor J.L.B. Smith, the best ichthyologist in the country. He nearly collapsed. He wrote back, "I would be less surprised if I met a dinosaur walking down the street." That fish was a coelacanth. The scientific world believed every single one of them had been dead for 66 million years. Coelacanths appear in the fossil record around 410 million years ago, 175 million years before the first dinosaurs. They swam while the first forests were growing on land. They survived the Permian extinction, when 90% of marine life vanished. They survived the asteroid that ended the dinosaurs. And then they vanished from the fossil record completely. No fossils, not one, for 66 million years. Every paleontologist on Earth agreed. They went extinct with the dinosaurs, until Marjorie proved them all wrong. But what truly stunned scientists was this. When they compared the living fish to fossils hundreds of millions of years old, the overall body plan looked almost the same. Same lobed fins, same basic shape, same heavy scales. That raised a question science still debates today. Why does this animal look like it barely changed while everything else transformed beyond recognition? The fins are the first clue. Most fish have fins supported by thin rays, like a fan. The coelacanth's paired fins are supported by bones arranged like a limb. A single bone, then 2 bones, then smaller bones branching out. The same pattern is in your arm right now. It even moves these fins in an alternating pattern, left front with right back, right front with left back, like a horse trotting. This fish doesn't swim like a typical fish. It moves in a walking rhythm. Then there's the skull. The coelacanth has an intracranial joint. Its skull is hinged in the middle. It can lift the front half upward to open its mouth wider. Almost no other living animal does this. And the notochord. You and I have a spine made of vertebrae. The coelacanth's vertebrae are barely developed. Instead, it retains an oil-filled elastic tube running the length of its body, a structure that in most vertebrates exists only in the embryo before being replaced by a spine. In the coelacanth, it stays for life. Deep inside its body is a fat-filled organ homologous to a lung, meaning it shares an evolutionary origin with the lungs you're breathing with right now. In the coelacanth, it doesn't function for breathing. It's calcified and fat-filled, but it tells us something profound about what this lineage once was capable of. This animal is not a failed experiment. It's a living window into what the ancestors of all land vertebrates might have looked like, a close relative of the lineage that crawled out of the ocean and eventually became you. Here's the big question. Why does it look so similar to its ancient relatives? First, let's kill a myth. The coelacanth is not unchanged. The living species, Latimeria chalumni and Latimeria menadoensis, are not the same species found in the fossil record. There were over 130 known species of coelacanth across dozens of genera over 400 million years. The 2 species alive today belong to the genus Latimeria, estimated to be only around 20 to 30 million years old. In 2013, scientists sequenced the coelacanth genome. They found its protein-coding genes are evolving, but slowly. Slower than almost any other vertebrate measured. Its regulatory elements, the switches controlling gene expression, are also changing slowly. So the question isn't, why did it stop evolving? Because it didn't. The real question is, why is it evolving so slowly? The answer is likely a combination of factors. Generation time. Coelacanths are estimated to live 60 years or more. A 2021 study suggested they might live up to 100 years and don't reproduce until age 40 to 50. Longer generations mean fewer opportunities for mutations to spread. Metabolic rate. They live in deep water, 150 to 700 meters down in volcanic caves along steep ocean shelves. They drift and conserve energy. Low metabolism correlates with lower mutation rates. Stable environment. Those deep ocean caves haven't changed much, so there's less selective pressure for dramatic physical change. Evolution didn't forget about the coelacanth. It found a way of life where the cost of change was higher than the cost of staying the same, and it worked for millions of years. Then in 1997, marine biologist Mark Erdman was on his honeymoon in Indonesia, walking through a fish market in Sulawesi. Sitting on a cart was a coelacanth, 10,000 kilometers from Africa. It turned out to be a second living species, genetically distinct from the African one, split an estimated 30 to 40 million years ago. We've mapped the surface of Mars in higher resolution than our own ocean floor. Over 80% of the ocean is unmapped, unobserved, and unexplored. A 5-foot armor-plated fish with limb-like fins hid from human science for 66 million years, until a curious woman on a dock looked closer. We don't know what's down there. We don't even know what we're not looking for. A 5-foot armored fish hid from science for 66 million years. If that was hiding in plain sight, imagine what still is.